Hello, this is the demonstration of a drafting problem 2 from the textbook 300 and page number 390. This is a final result I'm expecting from the drafting problem number 2. So let's start with the part we already have. So let me close this one. So this is the part. As you can see, I pretty much used a very simple sketch with all the dimension available from the book and just simple extrusion. So starting from there, so we're gonna go start, mechanical design, and drafting. In this case, since we already have a template already made it, I'm gonna use the template I already have. There's a C size template, B size template. I made a 2 size already. So in this case, I'm gonna use a B size template. So I'm gonna go File, Save As. Then I'm gonna save this one. Instead of writing over the template, I'm gonna just make it as a drafting problem number 2, and so on and so on. So in this case, I already have one, so I'm gonna do it a little bit differently. So save. So good to go. So the first front view, then the right side view, then also I'm gonna have isometric view have a scale as well too. If you look at the book, the dimensions showing in the book, we have a front side. So as example, 1.255, 45 degree, datum M, and the couple feature control frames showing in the front. And we have the 3 features actually, the datum L, and flatness 0.005, parallelism 0.008 based on the datum L. Those 3 features are showing in right side. So I need 2 views. So I'm going to start with insert view, projection, then front view. And it's waiting for me. Oh, this guy. Then right away it will project it. Then click. All right. Then, as you can see, the front view will be projected. Oh, I forgot to turn on the frame. So then you can move wherever you want. The same, once you have a front view is projected, you can project it one more time based on this activated view. So go to insert view, projection, and projection. So if you go to right side, it will make the right projection, upper, lower, left. So in this case, I'm gonna go right. There we go. Then I can start putting the dimensions. So right over here, so I'm gonna change the dimensions. I'm gonna start with the 1.525. So I'll click. There we go. But now, as you can see, this dimension is not going to be what you expected because the default of this CATiA system now is a feet-inch system. So we have to change this the units continually as you adding the dimensions. So we'll change to numerical and dimension in inches. The third options, numerical value, dimension in inches. Then you can see it right away shows it. If you want to control the amount of a decimal point, that is right here. So instead of a 2-digit, you can go as a 3-digit or even bigger as well too. But according to the book, I need a 2-digit. There we go. And I need a 5. So I need this guy from here to there. Okay, let me take this out. I could just delete it. Then again, I need to make it as a numeric, dimension in inch, 2-digit. I have an angle 45, but that is the basic dimensions. So you're not actually the measuring those. So actually, it's relying on the feature control frame. So we'll talk about it later. So I need an angle. So pick up the angle dimensions and click, and you can see it very easily. You can create it angles. But again, we need to make this one as basic dimensions. So click, and you can change that with the frame one. So you can show it as a basic dimensions. So we have only 1, 2, 3 dimensions. And according to the book, it says it is 0.315 inches thickness. So I can activate this right view by double clicking the frame. Then I can go to, again, the dimensions. And I can very easily make the thickness right there. So let me put it right there. And also I'm gonna delete this. Alright, again, I need, it's a numerical in inches, and 0.315 inches, that one is a 3 decimal point. There we go. So I got it. Okay. One thing the CATiA has options for this dimension is, again, if you click the arrow, then it will change the directions depending on your preference, depending on how density it is. You can always choose those options as well too. There's some other options when we jump into the diameter and radius as well too, so we'll cover that later on. Alright, once all dimension is done, let's start putting datum. Let's start with the datum first. First, we have a datum L in the front, right there. And also we have a datum at the bottom. So we're gonna put it right there. So here's a datum feature. Click, and it's waiting for you to pick up the surface. So in this case, the front. This is our datum L. So I'm gonna click and move up and left. Then it's waiting for you to add the letters for you. So in this case, L is our datum. And done. As you can see, there's a position 1 anchor actually, the anchor, and also the symbol for the root is also available. So actually, if you move your mouse over this yellow, right click, and there's many options, you can also change it as well too. So as we're going throughout the drafting problem, we'll see more. So click outside, that is done. Then another datum is right here at the bottom. So again, datum, click. There we go. Then usually the letter automatically updated after the latest one. So since L was done, the M will be automatically appeared. So looks good. And now time to put let me do it this one. I'm gonna put the parallelism for this guy. So a little bit. So if you pull down, and there is a feature control frame option shows up, and pick up the feature. As you can see, it's going to be very strange move, but don't worry about it now. And use the shift key, you'll be able to move much freely. So let me put it right there first. We'll fix it later. So now we'll change it to the parallelism. Then I'll give a 0.06, and based on our reference M, and say OK. And here is one thing I want to get your attention. Again, once you put the first feature frame, as you can see, is that the shape won't be right. Many cases, especially the anchor position is not right. I want to have this anchor position right top position so they can be actually laid out parallelly. Also, the where you have your root with the arrow this, then I want to get rid of as well too. So to move your anchor position, use the Control key and click the anchor, and actually you will be able to move around. Okay, let me do it again. Like this. There we go. Then also this arrow, I don't want that. So I'm gonna application now symbol shape, then I don't want this the field arrow which is currently showing. I'm gonna change the no symbols. There we go. Then I can actually move this using shift key, try to make it parallel with what I already have. Something like this, and let go. There you go, looks much better. Also, if you don't like the way anchored also, then actually you should be able to move as well too. In many cases, not a big deal. Alright, that's not bad. There's another one, which is a perpendicular 0.31 on this side. So I'm going to zoom in a little bit. There we go. So feature control frame, based on this, right away you will see this. And change to the perpendicular 0.031. It's going to be based on again our datum M. Okay, exactly same thing. In this case, it's already parallel to what we will have it, so I won't touch it. But again, the root is not right, so I'm gonna change to no symbols. Again, if you want, you can bring it back a little bit, or using shift key, you have more freedom as well too. Looks good. This blue arrows are actually showing the where is the part origins. So depending on which view is activated, this blue the arrows will show which is the part origin will show up. So if you like to see, you can just leave it there. If you double click the other one, you can see where is your part origin is kind of showing up. So it doesn't matter. Actually, when you're putting it out, this one is PDF or actual paper, it's not gonna show up. All right, I have parallelism done, perpendicular done, the angular. I need the angular feature control frame 0.006 with the based on M. So another feature control frame, click, it's showing up. Again, it's going to be angular, and it's going to be 0.006, and it's going to be based on your reference M. Okay, and here. And one thing you notice is as soon as you added all the required the content for the feature control frame, same thing about root and where's anchored, everything show up. But one more thing you're gonna see is that there's a double arrow on the both side, which is actually it will be able to provide the way of direction of your feature control frame will be appeared in the drawing. So if you click now, and if you move, click the arrow, and if you move your mouse either right or left, you can see the shoulder will be created automatically for you. It's not bad, right? So I'm gonna have about this much of a shoulder showing up. Oh, there we go. Then it will be created. It's easy. Okay, in the position wise, you can kind of play with it a little bit. So click, then you get to get it. So it's exactly same as what you're seeing from the book. Now it's almost done. We are going to have parallelism on the back, and we're gonna have flatness on the front. as well too. Feature control frame, from view. There we go. So flatness 0.004. Flatness doesn't require the reference, so no reference here. And say OK. Again, as you can see, only problem will be the shape of your extensions and a root. So I'm going to change to symbol shape as no symbol. And that should be it. Then we like to make sure, we like to have parallelism based on your front, which is datum L. So you're gonna have a feature control frame for the back. Again, if it's not following or matching automatically, don't worry about it. We're going to take care of this later. Click. We're gonna have parallelism, and we're gonna have 0.08. Then it's going to be based on our datum L. Say OK. Alright, again, it's not going to be really work well with the snap automatically put it into, so using the shift key, and you should be able to control much freely. And let go. And again, the shape symbol is not right, so no symbols. Again, if you look at closely, maybe it's not going to be exactly matched well, so you need a little bit of manual work here. There we go. I would say it's all right. Looks good to me. So if we zoom it out, we got front view, right side of view, all dimensions there, and all feature control frames are there. Then it's good to go. So just for make sure people understand the right shape of this part. Well, this one is obviously easy to understand, but just for reference, I always have isometric view at the corner and the half size as well too. Also, once it is done, if you see the features are a little bit off, I mean too close to the border, then don't hesitate to reposition it as well too. All right. So I will have again the isometric view there. So I'm gonna insert view projection isometric view. Is waiting for you to pick up the right angles for your part. So if you rotate it something like that, if you pick any surface, then this scene will be shown as isometric view. That's why I recommended to make a part exactly look like the books you're showing. So if you choose very carefully, as you choose isometric view in your part, it will show as a really isometric view. Then if you pick up any view now, then it will bring it back to you. Then it will let you select the position for your isometric view. I will put it outside first because I want to have this one half scale. So this one, isometric view, properties. Then instead of a 1:1 scale, I'm gonna go with half scale. And also, if you want, you can turn on the hidden line. You can even give the axis, and so on and so on. If you turn on the 3D color, if you made add any colors for your part, let's say you made a color intentionally on the part green or red, by turning on the 3D color, actually those color you added will be show up. So, and also, if you bring it down at the very bottom, there is a view generation mode. So I'm gonna change that instead of exact view, I'm gonna change it to raster. And also under option of a raster, I will be able to change it to shading with edges. Then you can give them normal quality or high quality. You can choose. Then if you say OK, then you can see it. the isometric view will be shaded and half scale shows up. Then I'm gonna bring to the top corner, something like this. So that will help someone not familiar with or having limitation of capability of understanding those two separate views as one as the solid model. This will help them to understand. So almost done. One thing I didn't mention in the class is the notes, the general notes of your drawing. If you look at the page number 387, at the very bottom, the author is providing some example for the note. So for practice purpose, I like to recommend you to put note at the bottom, or you can do it as your background also too, so that it always stay there for you as well too. So like the text and right there, saying everything capital, notes, colon. Oh, that you should not do enter. Shift enter, and one is dimensions and tolerance per SME Y14.5-2009, and so on. So, okay, we'll keep adding the more note here. So in this case, I'm expecting at least the full note from your drawings as well too. Once you put the all notes there, if you're going back to the working view, these are now affected by any front view actual feature you're putting in at the top as well too. All right, that's the conclusion of this demonstration. I will do more demonstration as we needed it, so that you can get much familiar with those dimensions. So this Wednesday, which is January 22nd, then we'll start with the drafting number 5 and other drafting problem as well too. Right, thank you.